Sample 12.1 in the figure shown, assume that the piston and the weight are at the same elevation, the face of the piston having an area of 12.5 cm square and the face of the weight 125 cm square. The intervening passages are filled with water. What weight can be supported by a force of 450 newtons applied at the end of the lever? Then the diameters of the two cylinders are 75 mm and 600 mm. The face of the piston is 6 meters above the face of the weight, and the intervening passages are filled with oil of specific gravity 0.8. What force P is required to maintain equilibrium if W is 36 kilonewtons? So there are two situations here. The first is, that's why I put here for the first case H is 0, so they are at the same level. If they are at the same level, then the pressure at the underside is the same because we have same liquid, homogeneous liquid, and they are at the same level. So pressure at the piston is equal to pressure over under the weight. That's the analysis for the first part. Then P is 450 newtons, so we can compute this force that will push the piston down. So summation of moment about this pivot O here equals 0. So counterclockwise moment 450, P is 450 times 1.2 equals force that will resist compressive force times 0.2. So F is 2,700 newtons. Since pressure under the piston is pressure under the weight, because on the first case they lie on the same elevation, so they have the same pressure. So pressure piston equals pressure under the weight. So don't worry about the area because they have the same units, so it will just cancel the units. So pressure under the piston is 2,700 newtons over area 12.5 cm square equals weight over area, which is 125. So pressure is just force over area because the area is horizontal, so the pressure is constant. Weight therefore is 27,000 newtons, or in kilonewtons 27 kilonewtons. Then for the second situation, we sum up pressure between pressure under the piston face down to pressure under the weight. This time the face of the piston is 6 meters above the face of the weight. So pressure under the piston, P sub P, going down, so plus 0.8 times 9.81 times 6, then equals pressure under the weight W, PW. Since pressure under the weight W is equal to the weight, it should be in kilopascals. This is in kilopascals, kilonewton per square meter. So weight should be in kilonewtons, then the area should be in meter square. So P sub P plus 0.8 times 9.81 times 6 equals 36 kilonewton over pi times 0.3 meter, 600 mm in diameter, so 0.3 meter in radius square. So that's consistent. Pressure under the piston is 80.24 kilopascals. From there, we can compute the force. Force equals pressure, which is constant, times area of the piston. And the area of the piston in meter square is pi 0.0375 meter quantity square. So F is pressure under the piston, area of piston, so 80.24 pi 0.0375 meter quantity square. In kilonewtons, F is 0.3545 kilonewtons. In newtons, 354.5 newtons. Finally, summation moment about O equals 0. So P times 1.2 equals F354.5 times 0.2. So we can now solve for P. P is 59.08 newtons.